Are you coming here, please? Hello?
Hello?
Are
I
you
have
coming
just
here,
I have just a curiosity. Some companies, private company, are implementing your system.
Some private company.
Okay,
Hello?
thank you. We can move to the second presentation. The second presentation, Professor Espinosa from University de las Fuerzas Armadas in Ecuador. Professor Espinosa, I invite you to share your presentation. Thank you, Dr. Shaka.
Thank you, sir.
Espinosa is not here at the moment. Skip to the third presentation.
Wait. We can move the third presentation, the Dr. Francesca Maltinti. Francesca, are you connected? Okay, thank you. I invite you to
yes,
share
I'm here.
Okay.
Aiuto.
Just a minute.
Can you see my desktop?
Yes.
And my presentation?
Yes, too.
Okay, thank you so much. Thank you, Mr. Chairman. Good afternoon, everyone. I am Francesca Maltinti from the University of Cagliari, and I am going to talk about Sardinia granite scraps application road pavement layers. Before starting my presentation, I would like to thank my co-authors, James Rombi and Mauro Coni. During my presentation, I'm going to give you an introduction about this research project. I will discuss about its aim. Then I will give you some detail about the methodology developed, and I will discuss you the results we have obtained so far, and I will try to draw some conclusions. We are all aware that road construction requires a huge amount of natural aggregates, and we need to find alternative materials in order to reduce the use of non-renewable resources, and at the same time the amount of current waste materials that leads to the reduction of landfills. In Sardinia, one of the largest islands of Italy, quarrying activity of marble and granite used as ornamental stones has been very active for decades, and it produced over 40 million cubic meters of granite byproducts. So, the aims of this research are to determine physical and mechanical behavior of granite scraps and compare these results with those of natural aggregates that normally are used in the road industry, and to verify in which way different excavation techniques influence physical and mechanical properties of granite byproducts deriving from the same rock. The excavated granite was originated from the excavation of three main tunnels called Maripintau, Stellas, and Mortinedo, with a total length of 4.1 kilometers, and two service tunnels for the realization of the new state road number 125, located on the southeast coast of Sardinia. The estimated excavated material resulted in 800,000 cubic meters. A tunnel boring machine was used for the realization of several tunnels, while drilling and ballasting technique was adapted for the realization of the three main tunnels. Three types of granite byproducts through laboratory tests were tested. The first, named by code AG1, derived from the excavation of two service tunnels using an open-shield TBM machine. The second, named by code AG2, derived from the excavation of the main tunnels using DB technique. The third, named by code AG3, derived from the excavation with the DB technique, and the larger blocks were reduced in size using a mobile jaw crusher with a feed size ranging from 600 900 millimeters, obtaining a material passing at 50 millimeter sieve. The samples were collected according to the UN 932-1 specifications for stockpiles and reduced according to UN 932 to perform tests. First of all, leaching tests were carried out in the lab to ensure that no hazardous compounds were contained in materials. The results showed that only fluoride was over the maximum concentration limit for sample Ag2 and Ag3. Such values can be attributed to the type of explosive used during the DMB excavation method. Then, in order to evaluate the uniformity of the geological body that we were dealing with, tests on the chemical and mineralogical composition were performed on the material deriving from the main and the service tunnel. After these preliminary characterizations, specific tests were performed to analyze the use of such materials in road pavement layers. Particle size distribution was conducted according to UN 953-1 specification. In the figure, the average particle size distribution of the three materials are reported. If compared with the grading imposed by the Italian Ministry of Infrastructure and Transport for unbound granular layers of foundation base layers, these materials must need further screening to have the correct percentage of aggregate fractions. Also, Attenberg limits tests were performed to classify the aggregates and they resulted non-plastic, while sample Ag2 and Ag3 didn't reach the minimum value of 40% for the sand equivalent test. To measure aggregate toughness, Los Angeles abrasion test was performed. The slightly high value obtained performing the Los Angeles abrasion test on Ag1 aggregates can be explained by the shape. They have a flat and elongated form that tends to disaggregate more easily. Mixture and density relationship was obtained by performing laboratory compaction using the modified Proctor method. Finally, cement-bound granular material layers were studied and tests conducted to evaluate the performance following the specifications imposed by the Italian National Center of Research 29 of 1972. Specimens were molded using 5 different percentages of Portland cement contents ranging from 0.5%, 1.5%, 2%, 3%, and 3.5%. According to the specifications, it is possible to use a cement content of up to 5%. The tests conducted on CBGM specimens have shown, according to the specifications, that the two types of granite scraps tested Ag1 and Ag2 achieved excellent compressive strength values with low cement content, respectively 2% and 1.5%. All that said, we can state that granite scraps can be used for road construction purposes. The results obtained from tests suggest some tricks to improve performance. Washing the aggregates must be performed to reduce fluoride contamination when it appears. If they are to be used in foundation and base layers, they need to be crushed and screened in order to have the correct fractions to achieve the specific blend. In CBGM layers, this type of aggregate can achieve good values of compressive strength with low percentage of Portland cement, only 2%. So the test conducted demonstrated how granite scarps can be used with high performance in road pavement structures, contributing to the reduction of quarrying new materials and introducing a circular economy approach with several benefits for Sardinia Island. Thank you for your attention. There are any questions?
Thank you, Francesca. Some questions? I have one consideration. I'm one of the authors. Thanks to this study, the Sardinia Regional Administration released a regulation to impose the use of the waste granite material in the public work. Thank you, Francesca. The presenter is Dottoressa Nicoletta Rassu. Please, Nicoletta, can you share your presentation?
Okay, can you hear me? I'm going. Yeah. I'm going to. Ok. Dunque, com'è che funziona? Blocca, scegli schermo. Schermo intero? No. Sì,
allora,
sì, se lo sto facendo.
Il tastino per la condivisione dello schermo.
Un po'.
Ok, adesso.
Can you see the presentation?
Yes, full screen, perfect.
La vedi?
Yes,
Prego,
sì.
puoi iniziare.
Okay, sorry. I'm introducing myself. I'm Nicoletta Rassu. I'm a researcher of DICAR, University of Cagliari, and with my colleague Francesca Maltinti and Alessandro Plesani and Franco Pinna, we've done the paper titled Sidewalk Cafe Analysis of Safe Solution for Customer. So, in the current times, with increasingly frequent manifestation of critical environment events, and especially with the pandemic from COVID-19, I've seen the need for a profound review of urban public spaces. As a result of the epidemiological situation of the last 2 years, we have focused our attention in this research on the response that urban spaces may provide to changing requirements. In particular, we focus on the criticalities experienced by operators in the catering sector, forced to respect the prolonged cycles of business closure. In addition, during the opening phases, since these were governed by the preference for open spaces that not everyone had, a disparity was created between the operators. This has also been observed by local administration, who have tackled the problem by modifying plans and regulatory instruments. In particular, to help operators in difficulty where possible, they have assigned in the concession public road spaces, sidewalks, part of carriageways, etc. The analysis was made in Cagliari, a municipal reality in southern of Sardinia. Before moving on to the case study, in the following slides, we show the situation in Paris and Toronto. The Paris regulation was published in the Bulletin officiel de la Ville de Paris on 2021. For the whole of the public road sector situated in the territory of the city of Paris, the regulation lays down the rules applicable specifically to installation of car parks. The conditions for the authorization and operation of the doors on parking lots are the length of the installation is limited to the linear of the facade. The structure must live inside the marking on the ground representing the dimension of the parking lot. The regulation also allows the use of parking stall in parking lots located on the other side of the roadway, even in the street open at any time to traffic, but whose maximum authorized speed is less than 50 km/h. The perimeter of the terraces on the parking lot shall be equipped with uniform barriers or protection screens, fixed in such a way as to guarantee their solidity and stability in order to ensure the safety of customers against traffic and prevent any fall towards their roadway. And sidewalk cafe, parklets, and marketing displays on the Toronto Municipal Code is particularly detailed with the prescription of the DORs. First of all, for the R, or generically called sidewalk cafe, they distinguish them according to the location in the roadway, and specifically, curbside cafe is a sidewalk cafe that is located on a curbside. Frontage cafe is a sidewalk cafe that is located immediately adjacent to the frontage wall of the associated establishment, And parklet cafe is a type of sidewalk cafe that is temporary lateral projection into the curb lane or parking lane of the street. The Article 7.1 establishes minimum width between the permitted encroachment and the adjacent pedestrian clearway, depending on the type of the road. Further detailed requirements are established for each type of coffee sidewalk, and expressly for parklet cafe, it is stated that the concession can be granted if the parklet cafe is located on roads where the limit of 40 kilometers per hour is imposed, or even where it is possible to exceed this limit once elements such as the number and width of the lanes, traffic flow, speed, and the other safety considerations have been assessed. Further precise provisions are established related to the distance with intersection or pedestrian crossing. The Cagliari regulation was issued by the Municipality of Cagliari, approved by the City Council with deed number 72 on 2018 and subsequent update. In its first version, the regulation did not allow any type of occupation of the roadway and or parking spaces. This prohibition was lifted with resolution number 79 on 2021. The update of the resolution was done precisely to respond to the contingent epidemiological circumstance. The regulation as well as 25 articles and governs the procedure for issuing temporary concession of public land and the method of use of related spaces. It is aimed at public operator for the administration of food and beverage for artisanal and commercial businesses. Concession, the maximum allowable areas of which are regulated by Article 12, may, however, be subject to limitation on release for the most varied reasons of public interest, including safety reasons, with particular reference to road and pedestrian traffic. For the purpose of the study, the article contains information on the regulation of concession spaces is number 13, which refers precisely to the management of spaces on the carriageway. According to the regulation, the areas of public land that can be granted are those in front of the production activity and adjacent to it, and those in front but separated by the carriageway only in condition which the carriageway has only one lane and is one way, the travel speed is limited to 30 kilometers per hour, and finally the pedestrian crossing is within a radius of 20 meters. In the light of the analysis of the contents of the regulation and its updates, in favor of public establishment that carry out the non-occasional activity of outdoor administration of food and drinks, which not have or may have other public or private outdoor space, the spaces that fall within the parking stall are allowed under concession, provided that these concern local roads, including the 30 zones, and provided that the space taken away does not create any prejudice for road and pedestrian traffic. The relevant aspect also concern the protection of the spaces that must be made safe through system designed to guarantee the protection of the installation in terms of the impact resistance of the system themselves, their visibility at night, and compliance with the regulation on road traffic safety. However, still with regards to protection, this must not be carried out through masonry, closing or grounding works of any kind. This last criterion, namely the protection of the roadway granted under concession, is the most controversial and main topic and subject of the study. The current analysis took into account the Cagliari scenario. The municipality of Sardinia capital, in response to the epidemiological emergency from COVID-19, as mentioned in the previous slides, integrated its own regulation by granting concession on carriageway spaces. However, following its approval, which dates back to May 2021, in the following July, the concession of public land were temporarily suspended due to an accident involving two vehicles passing through the intersection between Via Istria and Via Molise, in an area temporarily granted to a public establishment in order to use it as a refreshment area. Although the accident was of a modest entity, the barriers erected to defend the occupation failed to withstand the impact, to the point that one of the vehicles invaded the area and the equipment present, fortunately without causing any harm to people, as at the time there were neither customer and no passerby. This incident highlighted critical concern regarding the safety of concession located in carriageway space. This is why the municipal administration was forced to suspend the concession in order to assess the applicability in terms of safety. In the solution proposed by the regulation and adopted by the municipality, a series of critical issues were observed, which can be summarized as follows. The accident showed the lack of protection of the concession space, especially toward customer and staff. In fact, the use of the roadway to position the setups of commercial activity and obviously also the customer, not providing for any invasive protection that act as a real divider between the two spaces, pose a safety problem, especially for the former. However, there have been individual and uncoordinated initiatives, such as the fixing of removable New Jersey barriers, flower boxes, pylon, etc., which had in the intention the sole purpose of delimiting the space under concession without any claims in terms of cushioning and dissipation of the impact energy and therefore of protection in the event of a vehicle diversion. The proximity to the space traveled by vehicles, in addition to the aforementioned safety problem, exposure customer and staff to exhaust gases, with all that this entails in terms of public health and in the workplace. The current layout of the platform, in fact, interrupts the continuity of the pedestrian path. In this configuration, the sidewalk becomes an internal transit area for the staff and customer who make the move activities, refreshment area activities, as well as a waiting area for customer waiting to sit at a table or pay the bill. This element could create an interruption in the pedestrian flow, a circumstance that will become a real nuisance, if not a really criticality, special for users with reduced mobility, both for disability and for contingent or temporary situation. According to the regulation, the concessions are required to be issued in the street in third zone, one way and with a low volume of traffic. Regarding this last point, it is necessary to make an observation to clarify what is commonly defined as a 30 zone. According to the CDS, a 30 zone is an area of the urban road network where the speed limit is set equal to 30 kilometers per hour. In logic, the containment of speed would have the purpose of promoting coexistence between the various components of traffic, cars, bicycles, and pedestrians. It follows that, according to this definition, it is sufficient to limit the travel speed to 30 kilometers per hour and to affix the vertical signpost to delimit 30 areas. The proposed solution was planned to respond to the two fundamental needs: maintaining the continuity of pedestrian path by removing external interference that can make transit difficult, especially for users with reduced mobility, and the space intended for public concession must be adjacent to the building and not on the opposite side of the pavement. From this perspective, the intention was to reverse the intended use of the spaces, using the extension of the carriageway as a continuity of the sidewalk and placing the merchant supply adjacent to the building as shown in the figure. Our proposal as following strengths. The continuity of the pedestrian flow is ensured without any interference. In fact, the mere fact that the concession space is adjacent to the building means that both customer and staff gravitate around the granted area, effectively eliminating the flow crossing the sidewalk. The safety of traffic patrons is guaranteed. In fact, according to this configuration, the vehicular current is separated from the concession area by a space that is in fact a sidewalk and as such does not require protection. It should be remembered that the sidewalk is an area of the road intended for pedestrians that must be raised or, in absence of the rise, delimited and protected. This protection can be obtained simply by creating a shaped edge. The possibility with this intervention to rethink the dimension of the vehicle lanes, bringing them to value than elevator speed control. The improvement of traffic condition on internal roads within 30 zone as the extension of the sidewalk is useful for delimiting the perpetual space for the driver, making him think he is crossing a bottleneck, with a result of reduction in real travel speed. The solution adopted up to now by the municipality is applicable only to the roads including the 30 zone and one-way traffic zone. The proposal, due to its characteristic and the resulting advantage, potentially has a great scope. In fact, it is achievable not only in 30 zones, but also in all the local and residential roads characterized by two-way traffic and with 2 total lanes, as long as they are not affected by important flow. In conclusion, we have examined the solution that the various administrations we have proposed to support the growing needs of operators in the sector in order to find a functional and valid answer, especially in long-term perspective and not only subject to the period pandemic. The direct examination concerns the reality of Cagliari, a city about 154,000 inhabitants and with high concentration of bars and restaurants in historic and non-historic districts. The study revealed that the commitments made by the municipal administration and the solution proposed in this regard were not without critical issues, brought out 2 kinds of problems. In the first place, the safety of customer and staff, where adjacent to the vehicular current are exposed to the risk of investment in the event of accidental diversion of a vehicle. And secondly, according to this configuration, the sidewalk becomes a crossing and rest area for customer and staff, effectively creating an interruption of ordinary mobility and creating inconvenience, especially for weak users. Based on the analysis, the critical issue can be removed in full, but by completely reversing the intended use of the space. In this way, the safety of traffic and customer is guaranteed, as the vehicular current is separated from the concession area by a space that is in fact a sidewalk. The continuity of the pedestrian flow is granted. In fact, the mere fact that the concession space is adjacent to the building means that customer and staff gravitate around the granted area, effectively eliminating the flow crossing in the sidewalk. Thank you for your attention.
Thank you, Nicoletta. Thank you so much. There are any questions? There are any questions, Nicoletta?
I can hear you, Mauro.
Now? Now can you hear me?
No, it doesn't work. Okay.
Okay. There are any questions? Just one comment, Nicoletta.
Okay. Now I can hear you.
Okay. I think there are some public discussion about the solution. The coffee and bar owner, how think about the solution?
You mean a coffee? The owner of the bar is? You mean them? Yeah. Okay, I think if this solution will practice, I think they are happy because now almost in Cagliari now everything is blocked, but because there was the concession is suspended. Stop it because they don't have put the solution as well.
Alternative.
The alternative, yes, of course. I think this solution is because it's very easy. The reverse of the destination of the path. I think it's because it's easy. Is the practice solution? No, I mean. Yes. So,
thank you, Nicoletta. Now I can see Professor Espinosa. No, Professor Espinosa is not connected. We move to the last presentation, Dr. Al-Dulaimi. This is an additional presentation, just in time. Dr. Al-Dulaimi, you are connected, yes?
Yes, here I am here.
You
hear me?
Yeah, I can hear you. Please share your presentation and start. You present a research about comforting and safer highway.
Yeah.
Please.
Yeah, thank you. Is it clear for you, my presentation?
Yes, fine.
Yeah, okay. I am Hamid Ikmal Abdulaimi from Iraq. I am a PhD student in Sfax University in Tunisia. My presentation is part of my PhD thesis, is comforting and safer highways overtaking for lane change based on vehicle speed advisory. First, we make a simulation for vehicle overtaking based on speed advisory system. The investigational situation of research related to vehicles ad hoc networks, VANETs, mostly set up utilizing a traffic simulator. In this proposed approach, all vehicles were equipped with a vehicle-to-vehicle communication link that operating according to IEEE 802.11b wave standard. The communication delay of vehicle-to-vehicle, which assumed normal solution, and the road driving scenario consists of 10 vehicles set as semi-automated vehicles SAV on highway. We proposed the flowchart or decision tree for overtaking. First, here we have to start. Here we start with moving over overtaking legal. If we take overtaking legal, if you know you must do lane keeping and don't change lane. If yes, having needs for lane change or no. If yes, suitable gap between your vehicle and the front vehicle. If yes, you can lane change. If no, you can wait for a suitable gap. Then the other hand is when there is no needs for lane change. If your vehicle speed is greater than the neighbor's vehicle or the front vehicle, if yes, you can take the action, and if no, you can lane keeping. If yes, there is if your speed is greater than V lane speed, as you know, there is a speed at each lane at highway. Then you must be within the limits. If not, you are allowed to make overtaking. Then with a suitable gap, lane change and overtaking, then resume the original lane because you are not your speed are not greater than lane speed. If yes, you can lane change. And not to you want to resume original lane, just lane change and go away. The phases of overtaking, we divide three phases. Phase A is the preparing of overtaking. Phase B is starting or initiate overtaking, and phase C is ending of or termination of overtaking. Here we show some of obstacles that we simulate in the traffic accident between two vehicles in order to force the other vehicles make overtaking maneuver. There is a traffic accident here. So this yellow vehicle forced to overtake and then resume to its original lane because this car or this vehicle moving in the velocity within the limit of the right lane on the highway. Also, we simulate emergency vehicle coming from behind in the second obstacle that we simulate it in order to forcing the other vehicles to make overtaking maneuver to clear the left lane. This is the emergency vehicle, and you see these two vehicles will clear the left lane because it's emergency, and then they resume its original lane. We can also simulate the overtaking maneuver to avoid the traffic accident ahead between two vehicles. As we see in the first part, this is a traffic accident here, and the other vehicles, it's make a decision to lane change and to pass or overtake this traffic accident. Also, we simulate the overtaking maneuver based on speed advisory system proposed by our approach to avoid the traffic accident ahead between two vehicles. The system advises the driver which the overtaking maneuver is allowed or not allowed and suggests speed and time required. You see this screen. When it's not allowed, it will appear in red color, and when it's allowed, it will be in a green color and suggest, as you see, car number. This is car number 3, and speed required 120 kilometers, lane change to 3, and here there is time required. When there is another vehicle beside the concerned vehicle, this is not allowed to overchange or to lane change because it is very clear to this vehicle. And when there is no vehicle around or neighbor this vehicle, it will be allowed to overtaking. You can see in the another slide. This is the concern. This is not allowed at this moment because there is a vehicle very close to this vehicle. This is with the flag. It's the current vehicle. This is coming in the left lane, but it is very close to this vehicle, so it's not allowed to overtake. So when it's pass at this moment, sorry. At this moment, it will turn to allowed when it's this vehicle will be not close or there is a space gap suitable for overtaking. And also, when emergency vehicle, when it's pass the vehicle can resume its original lane and keep moving. Conclusions: the result obtained from simulation analysis shown the general utility of the overtaking based on safety criteria. We must take in consideration the following: the overtaking velocity greater than overtaken vehicle velocity at least by 15%. The overtaking acceleration must be in the limit 4 meters per second square, and the overtaking vehicle the acceleration will be less than 5 meters per second square. The overtaking velocity within the limits of maximum lane speed. The minimum spacing gap between position of A and B vehicles prior overtake are available. For rainy, fog, dusty, windy weathers, the overtaking velocity must be between 15 to 20% less than the road speed limits. Cloud connection is very important to obtain navigation data, which is necessary for changing lane decision. When we want to exit from the highway, you have to take the navigation data, and there is a overtaking or lane change needs. Thank you.
Thank you, Dr. Abdullahimi. This point, I think the last point is very important. Not all the cloud connection, but the precision of the position of vehicles. Can you tell me about that? Something about that?
please, pardon, I can't hear your
We're talking
question.
about the connection, the cloud connection, and the
Yeah.
precision for position.
Yeah, cloud connection is it's necessary for navigation information and weather information, and also for traffic situation, not in the current road segment, but in the all highways. As you know, the cloud connection is not limited by the range of VANET. VANET is limited between 300 meters to 1,000 meters for transition. But the cloud, it will be based on 5G or 4G communication. It will have a wide coverage area, so you can connect with the traffic center, city traffic center, and make the real-time information about traffic situation by cloud connecting.
Thank you, Dr. Alduaimi. Thank you so much. There are any questions? If no question, we can close this section, this workshop. Thank you, everybody. Thank you for this nice presentation, and see you next year in Lesbo Island, I know. Thank you. Arrivederci, Natale.
Thank you, grazie.
Thank you.
Professore, si ricordi di compilare il form di valutazione?
Dove lo trovo?
Le mando un link in privato.
Grazie, arrivederci a tutti. See you, bye.
Bye.
Bye, bye.
Bye. Bye. Thank you.
Thank you, thank you. Natale, ci sei sempre, mi senti?
Poi? Mauro?
Nicoletta,
Sì, io ci sono. Ho spento... Eccoci qua. Ah,
non sei
scusa.
sola.
Sono... Ah?
Cosa hai
È andata
detto?
bene? Contenta?
Sì,
Sì, bene, bene. Mi sono un po' intortata nelle risposte. Vabbè, era un po' il mio English, il
Sei la
mio...
migliore.
Yeah.
Mo
Sono
se
con
ne preso
Franci.
un'altra e poi ce ne andiamo a lavorare.
Sono con Francesca. Adesso
Ah,
andiamo
sei
a...
in facoltà?
Sì, siamo qua in
siamo in
facoltà.
Francia è stata brava, Nicoletta,
moltissimo.
vero?
Mi devo
Sì.
fare un bel corso di inglese, altro che...
Anche io, anche quello. Statistica, inglese.
Fatti
Statistica
vedere.
inglese.
Fatti vedere, dice.
Io mi faccio sempre che ti devi far vedere, io vedo.
Non vedo Francesca.
Ah, è qua. Siamo in barca.
Mi vedi? Guarda che c'è altra gente, Mauro.
Qui da
C'è
me.
Natale.
No,
Questa stanza.
Anche tu fatti vedere.
come, non mi vedete?
No, hai la telecamera spenta e c'hai anche una mascherina. Che simbolo è?
Io mi vedevo.
No. No, non ti sei...
Vabbè, abbandoniamo questa stanza e ce ne andiamo a quell'altra.
Vabbè, ci vediamo
Tu sei
nell'altra.
la chairman adesso, in Satra?
Sì, alle 16:40.
Ma ci si comprende che anche una cosa di Subrimu?
Adesso
Di quello della Nigeria.
no, io mi sono collegata tardi, Mauro, non ci ho capito niente. Ho
E
detto
perché
se
non hai fatto la domanda? Ti ho scritto fai una domanda.
Ah,
Ah, a me l'hai scritto.
Come no? Non hai risposto.
Mauro, non me ne sono accorta, ma me l'hai scritto su WhatsApp o sulla chat?
no, sulla chat non va
WhatsApp.
bene.
Su WhatsApp non l'ho visto, Mauro.
Vedi, Mauro con
Vabbè.
i sposi vuole scrivere... Ah, ok, quindi...
Ah,
Va bene. Bene, allora lo compilo. Vabbè, non lo so. Ok.
Perché
vabbè,
eravate
dai.
ancora qui?
Eh?
Perché eravate ancora qui?
E perché l'abbiamo lasciata aperta? Siamo in stanza, adesso andiamo a prenderci un caffè prima che Francesca faccia il chairman.
A che ora è, Franci?
16:40 inizia D'Acuzzo, James e poi tu.
Ultimo!
Sì, c'è un'inversione. D'Acuzzo mi ha chiesto di anticipare. E James
Invece il
ha già
professor
scelto il posto.
Espinosa, Università delle Sforzas Armadas, non si è fatto vedere.
È rimasto incastrato in Ecuador.
Va bene.
Vabbè,
Dai,
dai,
a
a
dopo.
dopo, Mauro. Ciao.
Ciao.
Quando mai ha avuto il telefono?
Hi, can you hear me?
Yeah.
Okay, thank you. Is there Francesca Martini?
Francesca Maltinti.
Sorry. Is there? Francesca? No?
I'm calling Francesca to give her a laugh.
Can you repeat, please?
Ciao Mauro.
Ciao Mauro, come stai? Sto chiamando Francesca, ero con lei poco fa, poi deve avere problemi di connessione.
Tutto bene.
La voce è caldo, sì.
Troppo.
Franci, stiamo aspettando te. Dai. Connettiti. Arriva.
Good evening, good afternoon to everyone. Hello, Mauro,
Hello.
James.
Hello.
Okay. So we can start this session. And I remind you that you have got 10 minutes for each presentation and 5 minutes for questions. Let's go start with the first presentation by Mauro D'Apuzzo. The title is Safety-Oriented Road Asset Management Methodology for Urban Areas. Mauro, the floor is yours.
Thank you. Thank you, Francesca. Thank you all. I'm sharing my presentation. Please let me know if you can see the presentation.
Yes, we can see it.
Okay, we can start with this presentation dealing with safety-oriented road asset management methodology for urban areas. This is works that I'm presenting on behalf of my co-authors, Azzurra Evangelisti, Giuseppe Cappelli, and Vittorio Nicolosi. General layout of this presentation is starting from an introduction. I will move to the methodology description, then I will show how this methodology has been applied to a case study, and then I will expose some preliminary conclusion. What we are talking about, obviously we are facing a very huge challenge in the transport sector. Within European Union, we are aiming at reaching some very demanding goals, such as the completely reduction of deaths in road crashes by 2050. And obviously, we can accomplish this very demanding goals by implementing new technologies, so smart road, but also maintenance need to be renewed and redesigned in order to comply with this new technology. And with reference to this subject, we can introduce the concept of asset management that can be defined as a systematic and coordinate activities and practice through which an organization optimally and sustainably manages assets and asset system and their associate performance, risk, and expenditure over their life cycle for the purpose of achieving its organizationally strategic plan. The main aim of road asset management are more efficient management of ordinary and extraordinary maintenance operation, rational support for decision making, and road asset risk evaluation. Well, as a matter of fact, recently we also deal with the implementation of some resilience concept in road asset management, since also resilience is perceived as an important criteria that should drive the highway manager decision for the road asset management. On a schematic point of view, road asset management encompasses all the system composing the roads, such as drainage and stabilization, safety barriers, so roadside furniture, vertical and horizontal road markings, road pavements, street light device, and so on. And obviously, on the other side, we have different criteria that will drive decision on maintenance intervention for all this system. That could be obviously related to user costs, management costs, environment, hydrological and seismic risk, security, and the last one, but not the least, the safety. So in this paper, we just analyze how safety can affect the road asset management procedures that can further be defined as a tool for delivering a more efficient and effective approach to the management of highway infrastructures. Let's go straight on to the methodology that we developed and we applied to this case study. We start from safety inspection, and we use the data collected with safety inspection in order to gain information on asset condition. And we combine the asset condition with site crash analysis in order to gain a prioritization of maintenance intervention, and according to a specific budget scenario, develop a maintenance plan, maintenance program over a specific time span, namely a 3-year long time span. What we start from safety inspection. Safety inspection are important and relevant tasks that were firstly introduced in actually at the end of the last century, we may say. They were more correctly named safety audit, but recently this safety inspection have been the main topics of the European Directive 2008 that has been transposed to the Italian context by means of the Ministry Decree number 35 of 2011. And following this Minister Decree, there were also released, as some of you will certainly know, there were also released ministry guidelines in 2012 in order to provide some information and general procedures for safety management of road network. We were obviously the main aims of safety inspection is to identify road infrastructure problems. They may constitute potential dangers of situation, define a prioritization of corrective intervention in order to reduce number and severity of accident, and monitor in a continuous and systematic manner the safety condition of road network. The organization of this safety management procedure in such a way that is the way how is exposed and showing the ministry guidelines is based on a circular procedure when you start from a classification and a classification of the road network, planning of intervention, and therefore in the next phase you will have a further network analysis and then an inspection, and that will modify classification and so on. So this is a sort of iterative procedure that has been proposed within these ministry guidelines. Obviously, as far as safety inspection are concerned, we can find some aspect related to inspection program and identification of inspectors and requirements that should comply an inspector, and obviously some very general procedure for performing inspection and how to analyze results and data collected by this inspection. The Lazio Regional Highway Agency asked us to develop and define a more refined procedure to carry out safety inspection according to the ministry guidelines. So within this contract, we study much more operative procedure in order to carry out these safety inspections, such as, for example, the design of motorcade layout according to different period of the day when you need to perform the safety inspection. Obviously, position of inspector in the inspector car, and obviously a complete redesign of the checking list that are required in order to carry out this safety inspection. The idea that we have is that if we can use this safety inspection in order to identify critical assets that need to be they need to undergo to some intervention in order to improve safety, we can also use this same data in order to design or to develop some maintenance program within a more general asset management system. So we came up with this procedure where we start from an accident analysis of the road network. In this reference is a urban road network, and we collect data on accidents occurred on this road network, and by combining that accident data with traffic data, we can obviously there is some accident rate estimation and compare these values with average value in order to identify a critical road section that needs to be focused, that needs to have some intervention that should improve safety level. So once that we identify the critical section, we, by means of what we call an incident matrix, a matrix that will that is based on relationship between accident type and on one hand, and road system, road infrastructure systems such as, for example, pavement or roadside features, or street lighting and so on. All the system composing the road asset management, we can came up to a prioritization method that will allow us to evaluate the best intervention for a specific critical road section. And once that we have identified this intervention, we can scheduling this intervention according to a specific budget scenario. We applied this methodology to an overall road network of 30 kilometers long in 4 urban areas, since, as a matter of fact, the Lazio Highway Agency is in charge to manage the maintenance also of some urban road section. So we need to collect data on road condition also on urban area. And we came up with about 300 homogeneous sections on which we collected this data that were the base on which we calibrate this methodology. On the other side, we collected data from the ISTAT database, the statistical agency, Italian statistical agency that is in charge in collecting accident data, according obviously this accident classification, and obviously we aggregate these different 12 accident type into a more reduced amount of accident type in order to develop a accident index that can allow us to identify critical homogeneous road section that need to be upgraded or need to have a maintenance intervention. On the other side, we start from 7 different road assets. So horizontal road design, vertical road side, hydraulics system, safety barrier, street light, pavement condition, roadside condition. Obviously, I'm referring to safety barrier. And no, not vegetation, sorry, because roadside safety barrier we already deal with. And we came up with a frequency distribution of level condition for each of these assets. And obviously, we also consider a different type of intervention for each of these assets. We can see, for example, the intervention that we evaluate for a typical pavement asset, but we evaluate also other conditions, for example, horizontal markings. We just consider the resurfacing, the renewing of horizontal markings. And we allocate, basing on a specific budget scenario, this intervention overall on the critical homogeneous road section in order to have a multi-year maintenance plan. As you can see, after each year, we can use most of the budget that has been devoted for the specific road asset system, but sometimes, especially in the first year of the program, we can have a remaining sum that we can use in the following years in order to complete the maintenance intervention plan for all the remaining critical road section. Conclusion. A simplified road asset management system for local agencies and municipalities has been proposed. The main aim of this method is to improve road safety, combining traffic and accident data with current performance condition of the network. Input data can be easily collected from public database and from safety inspection. And the output of the method is the multi-year scheduling for an ordinary maintenance intervention on the main road asset. Methodology can be simply implemented in a conventional spreadsheet. So this is, I see, one of the most interesting features of this methodology, since it can be, as I told you, implemented in a simple spreadsheet. So also small municipality can use this approach in order to plan on a rational way the maintenance of their asset. Thank you very much. I'm waiting from question if there will be any.
Mauro, just a question. The problem is the budget.
Yes. How can, just a curiosity, actually, we evaluate the budget basing on a global service contract that was already operating in the regional highway agency. We just skip a part of this budget for the urban road network. So that budget scenarios is very realistic because it's based on a global service contract. Okay.
Yeah, I know. In Cagliari, we are linking the global service to implement the accident risk. I found your research very interesting. We need to talk in Cagliari administration to involve this kind of approach.
Yes, I'm available to work with you with this.
It started the new global service for the 5 years, and we are starting just this month. This
as far as I know, I don't know if you agree. As far as I know, one critical aspect in global service is the performance monitoring. You need to develop a very effective way to monitor the maintenance and the performance of maintenance of the contractor. Otherwise, obviously, the global service is I wouldn't say
just a collected data that remain in the in the municipality without using. Thank you, Mauro.
Thank you too.
More questions? Okay. Let's listen the second one presentation by James Romby, who is presenting as a performance evaluation of in situ application of anhydrous calcium sulfate in pavement layers. James, the floor is yours.
Thank you very much, Francesca. Can you hear me?
Yes.
Okay.
Okay, we can see your presentation, James. You can start.
Okay, thank you very much. So the title of this presentation is Performance Evaluation of In Situ Application of Anhydrous Calcium Sulfate in Pavement Layers. Before I start my presentation, I would like to acknowledge the other authors of this research, that are Marco Lianas, Marta Salis, Andrea Serpi, and Mauro Coni. So the following slides are going to cover some issues of this research. There will be a short introduction. I will talk about the aims of the research, then the case study, tests conducted and results, and finally conclusions. So, as we know, cement is one of the most used material worldwide. Its annual production in 2020 has reached approximately 4.1 billion tons, producing around 1.4 billion tons of CO2 per year. That is about 8% of the total CO2 emitted in the atmosphere. Half of this CO2 derived from using fossil fuels to heat the kilns, and the other half is produced through the calcination of limestone. As I said, cement is widely used in civil engineering, especially in road construction industry. Some examples like construction of bridges, tunnels, and concrete roads, but also it can be used for the treatment of aggregates as a hydraulic binder and also for the stabilization of soils. In the road construction industry, there are many materials that are used, alternative materials like rubber, plastic glass, construction and demolition waste, and different types of byproducts. All these types of material are useful to introduce the circular economy, that is, reusing materials, minimizing waste. In this research, the potential application of the byproduct anhydrous calcium sulfate have been studied to verify the potential use in cement-bound granular pavement layers. So let's see what is a cement-bound granular material layer. This type of layer is located between the asphalt base layer and the granular sub-base layer, and is formed of cement, granular aggregates, and water, and they are mixed together and then compacted. The aims of this research are verify the potential application of anhydrous calcium sulfate, that will be called ACS, in road construction sector by partially replacing cement in bound granular material layers. Also, evaluate mechanical behavior in real working conditions, constructing and trial embankment. The anhydrous calcium sulfate, as I said, is a byproduct deriving from the process to obtain aluminium fluoride and chloride that is used in the aluminium industry. The company that has supplied this material is located in Sardinia. It has an annual production of 240,000 tons per year. And we must say that this is the byproduct, it's not the core production of this industry. Also, we can see the process from which this byproduct arises. So we got fluorspar, that is solid, sulfuric acid liquid, to obtain the core production of the company, that is hydrogen fluoride. And that from that, we have the byproduct, that is calcium sulfate, anhydrous calcium sulfate, that is the byproduct that we analyzed. So the case study was to construct a road embankment in order to verify the mechanical performances in real working conditions. The mixed design that was previously tested in laboratory is of 2% of cement and 5% of ACS. Here we can see some pictures of the trial embankment that was constructed. It was 90 meters long, 6 meters wide, and divided in 2 sections. In the first section on your left was constructed using the innovative mix, that is that one incorporating the 2% of cement and 5% of ACS. On the left, on your right, you got the reference mix, that is the normal 3% of cement that is used for cement ground pavement layers. We can see also the thickness of each of the layers. So we got 7 centimeters of binder, 10 centimeters of base layer, 20 centimeters of cement bound granular layers, and also 20 centimeters of granular unbound material. That is a total of 57 centimeters of height of the embankment. In order to perform the test and evaluate the mechanical performances, a falling weight deflectometer was used. As you can see in the picture, it is towed by a truck that is capable of measuring the deflections. So the falling weight deflectometer is a destructive testing device used to perform in situ tests on pavements. It is capable of measuring deflections obtained by applying an impulse with a falling load. From the data obtained, it is possible to calculate the elastic moduli of the layers. As we can see in the picture here, it is possible to see how the deflection basin chart. So we got the position of the load applied, and then we got from D1 to D10 that represents the position of the geophones. They are capable to measure at each of the layers the deflections. The testing campaign that was performed, we can see here. So the trial road embankment was constructed inside the industrial plant that supplied the ACS. It was constructed in May, and the first tests were performed in June. That is a month later from construction, and then replicated in September. So we had 2 sets of testing campaigns. On each of the tested points, as we can see here, the loading was repeated 3 times, each time increasing the load, starting from 1,000 kilopascal, then 1,350, and finally 1,550 kilopascals. Here in this chart, we can see the data obtained from the 2 campaigns. So on your left, you can see the chart that represents the contact pressure of 1000 kilopascals. You can see also lines in red and in blue. The lines in red represent the innovative mix, while the lines in blue represent the traditional mix. Also, you can see a continuous line of dashed lines. The dashed lines are the ones that represent the tests that were performed in September. That is at least 4 months after the construction of the embankment. As we can see, the deflection on each of the tests performed are lower. That means that the embankment, that layer of the embankment is curing, so it's maturing, so it's having a lower bearing capacity. And also we can see that the values obtained for the innovative mix show lower deflections. That means that it has higher values of bearing capacity. As I said previously, from the data obtained and using back calculation, it was possible to determine the elastic modulus of each of the layers that form the embankment. We will concentrate on the layers that are focused the research, that is the cement granular embankment layer. So on your left, you got the traditional embankment, and on your right, the innovative mix. As we can see for the first campaign, the values obtained comparing the traditional and innovative, there is an increase of elastic moduli of 28%. If we analyze after, in September, when the second campaign was performed, we can see also that is an increase passing from 2,800 megapascal to 482 megapascal. That is about an increase of 44%. So what can we say? We can draw some conclusions. We must say that this research is still in progress. So these are only some conclusions that can be drawn. And these are: the construction of the pile embankment highlighted some issues in the phase of mixing and laying the innovative CBGM layer. Optimum water content in the mix must be strictly respected. The laying and compacting procedure must be done in a short period of time to achieve maximum density and reduce air voids. Also, the falling weight campaign have highlighted an increase in stiffness for both the traditional and innovative cement mix, as curing time increases, with greater increase of stiffness of the section of the innovative mix design. From this initial research, we can say that ACS has the possibility to be a valid alternative to reduce the amount of cement in cement-bound granular mixes, reducing to emissions and also construction cost, because we must say that this ACS is a byproduct. So energy and also CO2 has already been emitted. This will lead towards a circular economy strategy. Also, we must say that this embankment is open to heavy traffic, and in the near future, other tests will be conducted and to evaluate how the bearing capacity is going along. Many thanks for the attention. Any questions?
Yes, if it's possible. I think, Francesca, you should switch on the microphone. Yes. Just a let me compliment for your very interesting presentation, James.
Thank you very much.
Just a curiosity. The time span between the first campaign and the second campaign was planned or unwanted? I mean, there were about 3 months, okay?
Yes.
I was just wondering, how do you have some information of, minimum curing time that you can suggest for this new mixes, cement plus obviously anhydrous sulfate mixes? So this is my curiosity.
No, the problem is, as I said, this trial embankment is open to heavy traffic, so it's used by the company that supplied. So it's not very. It's quite difficult to have access periodically to the plant. So based on the data, because based on the data that we perform in laboratory, we say that the actual curing time of this type of material, it's about between 2 months if we compare to a normal soil cement mix using like normal one using 3% of cement.
Thank you very much.
You're welcome.
Very clear.
Any more question? No more question? Okay. We can go on with the last presentation by Mauro Coni with the deflection and friction performance of waste wooden block pavement. Mauro, the floor is yours.
Thank you, Francesca. Can you see the presentation?
Yes, Mauro, we can see them.
Oh, thank you. Good afternoon, everyone. My name is Mauro Coni. You know, I am going to present a research about deflection and friction performance of wood waste block pavement. First of all, I want to thank to my co-authors, Giovanna Concu, Carla Carcangio, and Francesca Martini. As we know, the construction of road pavement has a significant impact of environmental. We remove aggregate from the nature, we consume a lot of energy for materials production, we have problems for the soil sealing, urban island, and so on. A sustainable solution is the use of the wood, but it is unclear and variable mechanical performance and durability. For this reason, the wood and pavement have a very limited use over history. But we have many applications in the past, and in this image and picture, you can see a typical wood pavement, Nicholson Road, that started about 100 years ago. Since this element is built with this very small element, it's possible to reuse the waste from wood manufacturing, giving the possibility to use the Sardinia wood, because in Sardinia the typical wood not have a structural value, and typical usage for combustion heating due to the dimensional irregularity, non-homogeneity, defect, noise, and deformation. Even small furniture in Sardinia come from the foreign markets. Of course, landscape tourism, emission reduction, and environmental integration with the local context could encourage its use if reliable techniques are available. Since wood element is a byproduct, almost the energy and emission for its structure have already been spent. But the complexity of the mechanical response of the element pavement and their interpretation are not well investigated, and many different and unconventional approaches are used in the past. For this investigation, we use a typical approach adopted by the road pavement engineers, and we implement the approach in situ, in laboratory, and through simulation, unit element simulation. A trial section of the wood element pavement was built in real scale and tested with a fully weight deflectometer. After that, we perform a finite element model to simulate different conditions of stress and geometric and dimension of the elements. And finally, in the laboratory, we test the friction of the wood, performing standard test with the precision equipment. The trial section was built in real scale, and we built a small pavement, 6 meter long, 4 meter wide. And we use the same technique used for the typical block concrete block pavement. with different layer wooden bricks. The substrate was prepared, leveled, and rolled, and then 5 centimeters of sand was applied to ensure the drainage. The folly weight deflectometer, many of us know, is an impulsive test developed specifically for road and airfield pavement to reproduce the wheel load transit. The vertical stress as applied with a control-shaped dropping weight on circular plate. At the same time, 12 geophones register the vertical velocity, and the data are collected and stored and integrated by the electronic system to evaluate the pavement displacement and for the post-processing. And this is the typical deflection basin. It's possible to estimate the value of the stiffness of each pavement layer throughout the calculation and post-processing evaluation. After that, by ANSYS software, we implement a structural analysis and simulation and a model of a small portion of the block payment is developed. And we can see the model. In lab, also we performed an important friction test through the British Petroleum equipment. And you can see that some video of that image. We tested 2 types of wood, eucalypt and maritime pine. And we tested the material in 2 directions, orthogonal and parallel fiber direction, because we have different results. And it's important things to install correctly the brick to have a good friction in the direction of the vehicles. Folly weight deflectometer test was developed specifically to have data to calibrate and validate the model. We performed 16 tests over the pavement with different stress levels, 6, 8, and 1000 kilopascals. On the sub-brake, before and after, we built a waste block pavement. This is the result, and you can see some irregularity due to the movement of the brick element that have a rigid movement under the folly weight. The folly weight is typical developed used for the pavement without crack, without joint. In the block pavement is a particular application of the folly weight, but from a structural point of view, the folly weight gives a lot of information to calibrate the model. After that, we confirm the film element method, and we can see the graph that show the pavement simulations versus the deflection testing. Simply, we have a good agreement. When we have the available a model calibrated, we use the model to analyze the behavior of the pavement in different configurations, block arrangement, and thicknesses, analyzing the stress-strain parameters, stress and displacement. From simulation, we can observe that as the thickness of the block increased, the stress distribution became more uniform, and of course the maximum deflection decreases. More significant difference occurred between the 4 different block configuration with vertical loads, and the maximum deflection increased dramatically with the as the thickness became less. About 70-80% for 8 centimeter, and 3 times for the thickness of 6 centimeter. Friction tests show a good and acceptable behavior. More precise, the eucalyptus show a very good friction characteristics, while the magnetic pine is poor, but acceptable. In conclusion, the research how to highlight some critical aspects using waste Sardinia hood to create block payment for light roads. The investigation suggests that reducing waste hood into small elements remove the effect of geometric imperfection, irregularities, and can ensure that payment adequate and reliable mechanical design. The mechanical response is complex, is non-linear, not linear. The deflection of hood payment are comparable with and similar those of the road hot mix asphalt pavement cracked. And finally, the coupling of the interlocking between the hood and elements is a critical issue, as we can. Thank you. Have you some questions?
Mauro wants to
Yes.
have a question. Mauro?
Thank you. Thank you, Mauro. I was really impressed by this presentation. Seems very interesting. I have a curiosity. I remember just, from my past studies on concrete block pavement that mechanical behavior of this concrete block pavement is mainly affected by the shear joint, the sand shear joint that is located on the lateral faces of, the elements, the brick. And you usually should apply some sort of pre-stress in order, to have a much better mechanical, interlocking, exactly. So I'm wondering, did you apply some sort of pre-stress in your experimental layout, or you just lay the brick and
No. We built the pavement, the cross section in the same way. We built a confined block, hood block, to confine the pavement, and we put the sand on the top of the block pavement, and we use the same technique for the concrete block pavement.
Okay. And another, if I can, another question: did you wet the sample before carry out the pendulum test? Just another curiosity.
No.
Okay.
No.
Okay. Thank you very much. I really appreciated your presentation.
Thank you, Mauro and Mauro. Are there any questions more?
Ok, Francesca, siamo tutti italiani in questo momento.
Ah,
quindi,
ok.
buon lavoro a tutti.
Sì, però la sessione dovrebbe essere registrata, giusto? Quindi qualcuno che se la vuole andare a vedere.
Esatto. Va bene, Mauro, ci sentiamo presto. Questa cosa del global service interessa molto. Proprio questi giorni stiamo mettendo a punto questa roba. In passato il global service è andato.
Innanzitutto mi fa molto piacere avervi rivisto, anche se a livello virtuale, tutti quanti. E poi sicuramente, mi fa piacere se ci risentiamo su queste cose. Va bene?
Va bene.
Faccio ancora i miei complimenti per i bellissimi lavori che avete fatto. Sono tutti
che sono i nostri
molto
coautori
engaged, mi sono piaciuti molto.
Anche
Grazie
noi,
Mauro.
Ciao, ciao, a
Grazie
presto.
a voi, arrivederci,
ciao.
a presto.
Ciao. Grazie a tutti. Thank you so much to everybody.
Bye bye.
Bye bye.
Ciao, bye.
Bye.
Bye. Bye.